Today we learned how to solve systems of equations by elimination. This is the third method that we've learned. The first one was by graphing, the second one was by substitution, and now we're going to do it by elimination. Remember that a system of equations means that you have at least two or more equations. If we have no solution, it means the lines are parallel and they do not intersect. So they have the same slope and different intercepts. If it's one solution, the lines intersect exactly once, and the slopes are different. If it's infinite solutions, it's the same line graphed on top of another line, and they're exactly the same. They have the same slope and intercept, and we talked a lot about how it might give you an equation like y equals 2x plus 4, and another equation might look like 2y equals 4x plus 8. And the second equation, all it does is double the values of the first equation. So if you can recognize that, you will know that you have the same line and that you will have infinite solutions. We show infinite solutions. That sideways 8. One solution, we'll write one solution and list it where they intersect. And a no solution, we do the circle with a slash through it. So the elimination method, these are your steps used to solve. The first one was to choose a variable to eliminate. The second step is to create opposite coefficients, then add the two equations. And coefficients, that is the number in front of the variable. So if I have 2x plus 3y equals 8, the 2 and the 3 are what are known as coefficients. And if we're trying to create, say, an opposite coefficient for our x value, then we would try to make the next equation say negative 2x so that we can eliminate those two. Your next step is to solve for the remaining variable. Once you've eliminated one of the variables in step 2, then you only have one variable left in step 3 to solve for. In step 4, you're going to substitute that known variable into either equation and solve, but I would say either original equation before you do any changes. And then your last step is to check your solution. So our first example says solve using elimination. Now, if you notice, the first thing you're going to want to do is choose a variable to eliminate. We could either choose the x's or we could choose the y's. But if you notice here, these have the same number. Step 2 says to create opposite coefficients. So if we take the top equation and multiply it by a negative 1, it will give you negative 2x minus y or plus negative y equals negative 6. And then we don't have to change the second equation. And then from here, I just say add. Some teach that you can just subtract, but I always like to create opposite coefficients and then just add. So when we add the negative 2 plus 2, this eliminates itself, and then you get a negative 1y plus 7y is 6y, and then negative 6 plus 12 is 6. And from here, this is step 3 that says solve the remaining variable. We divide both sides by 6, and y equals 1. Step 4 says you're going to take this known answer that you have and substitute into an original equation and solve. I'm going to take the top equation and replace this y with the 1 and then solve it. To solve it, we subtract 1 to both sides. You're left with 2x equals 5. And then to solve this, we divide by 2 and x equals 5/2, or you could say 2.5. So that leaves us with one solution located at 5/2 and 1. And what that means is if we were to graph these two equations, they would intersect at this point. The last thing you're going to do on this equation is check your solution. Our solution was 1 at 5/2 and 1. So we're going to put that into the top equation. 2 times 5/2 plus 1, and see if that equals 6. And I like to use the fraction. You can leave it as a decimal, 2.5, but I like the fraction because when you are checking, these 2's will just divide out, and you get 5 plus 1 equals 6. 5 plus 1 is 6, and it's true. Now, just because it's true in the top equation does not mean it's true in the bottom equation, so we check it as well. 2 times 5 halves plus 7 times 1, and we're checking to see if that equals 12. Again, these 2's will divide out, and you get 5 plus 7 times 1 is 7 equals 12, and we can see that 12 equals 12. It's true, so our solution does check, which means it's correct. Here's your second equation. Again, you're looking to eliminate a variable. I check for signs. If I already have signs that are opposite, then I'm going to choose to eliminate that variable. Another trick is to look at this number, and that number is what I'm going to multiply the second equation by. So I'm going to multiply the second number or the second equation by 4, and then use this number from the second equation to multiply the top, and that will help create those opposite coefficients. So when we multiply that top one by 5, we get 35x minus 20y. Now, make sure that you take that 5 to all 3 terms. Equals 85. We do the same thing with the 4, distribute it to all 3 terms. 12x plus 20y equals 56. Then we're going to go ahead and add these. Right here you should see that we have opposite coefficients. So when we add them, they will eliminate, and we add the 35x plus the 12x to get 47x. These are eliminated, and you get 141 on the other side. From here, we can solve for x. To solve for x, we divide by 47. These 47's divide out, and x equals 3. From here, you're going to go into an original equation. I'm going to choose the bottom equation only because there's no negatives and I don't have to worry about signs. So I go into the bottom equation and replace the x with 3, and then I solve this for y. So 3 times 3 is 9. Subtract 9 to both sides. Those 9's subtract out. 5y equals 5, divide by 5, and y equals 1. This tells us that we have one solution located at 3, 1. And again, you're going to want to check this solution. So our solution was at 3, 1. And we put that into the top equation. 7 times 3 minus 4 times 1. We're going to check to see if this is 17. So 7 times 3 is 21. Minus 4 times 1 is 4. 21 minus 4 is 17. So it checks in the top, but make sure it checks in the bottom. So 3 times 3 plus 5 times 1 equals 14. 3 times 3 is 9. 5 times 1 is 5. And we get 14 on the bottom equals 14. So it checks. It means that our solution is correct. Now remember that this solution means it's where, if we were to graph these two lines, it's where the two intersect. Alright, we have some special cases. If I were to look at this equation here, if I were to wanted to eliminate the x's, then I could multiply this bottom one by -2. It'll give you -6x. Now remember to take it to all 3 terms. Minus 4y equals -2. And then I'm going to bring this one down here. 6x plus 4y equals -1. And then I'm going to add these. Now when I add them, these eliminate, and I'm left with 0 over here, and then I combine these two to get -3. When you lose your variables, you're going to look at this statement. If it's true, then we have something, but when it's not true, like what we have here, then we have no solution. Now on the second one, I have to change this number to a -2. I have a typo. So again, we're going to use that same concept where we're going to multiply this bottom equation by -2, and that will give us negative 6x minus 4y, or plus a negative 4y, and then times the -2 to the -1, and you get 2. I'll bring this equation down here. 6x plus 4y equals -2, and I did make that change because I had a typo. And then we'll add. This will subtract, and we get 0. These also subtract, and we get 0. If 0 equals 0, if you get 0 equals 0, that means that it's true and that you have infinite solutions. And what that means is that these two equations were the same equation. Over here with the no solution, it means the lines are parallel and they will never intersect, so they have no solution in common. But here with the infinite means that if you were to graph them, they would graph as the same line, so they share every point in common. Right, your last example says that the drama club sold $200 worth of hot drinks. They sold 295 cups. If hot chocolate sells for 75 cents and coffee sells for 50 cents, how many of each did they sell? So when you're given a problem like this, the first thing that you're going to want to do is to find your variables. So I'm going to say H equals hot chocolate, and C represents the coffee. And then I'm going to use this one right here. They sold 295 cups. So if I add my cups together, I should have 295 total. And then I'm going to use usually this works out nicely, the dollars with the dollars. So I know hot chocolate sells for 75 cents, so I'm going to go 75.75 H plus 0.5, because coffee was 50 cents, and they made $200. Now, because these variables are lined up right here and here, I'm going to use the elimination method. So I want to get these to be equal, and so I'm going to, or not equal, I want to create opposite coefficients. So to create opposite coefficients, I'm going to work with the C's, and I'm going to multiply the top one by a negative 0.5, and be sure you distribute that through. When we distribute it, we get negative 0.5H minus 0.5C equals negative 147.5. I'm just going to rewrite this equation here. 0.75H plus 0.5C equals 200. From here, I'm going to go ahead and add. When I add, the C values eliminate themselves, and then we're left with negative 0.5 plus 0.75H, which is 0.25H, equals 52.5. We'll divide both sides by 0.25. These divide out, and you get H equals 210. So I'm going to use that information right here, and I'm going to put that right into that H right there. So I get a new equation that says 210 plus C equals 295. So what would I have to add to 210 to get 285, or 95? I'd have to add 85. So that tells us that the drama club, they sold 85 cups of coffee and 210 cups of hot chocolate. All right, that should help you with your equation, or with your assignment solving systems of equations by elimination.